Hi, my name is Rithvik, and I am the team captain and the lead engineer of FTC Team 16075 Crimson Crocs. First has shaped how I think about engineering, not just as building machines, but as solving problems creatively, especially when resources are limited. This season, we set out to build one of the most innovative robots our region has ever seen, and we did that fully committing to custom design. In Jamaica, access to specialized parts isn't easy. Shipping takes weeks, costs are really high, and if something breaks, you can't just overnight ship in a replacement. So instead of relying completely on off the shelf solutions, we transitioned to a CAD first engineering process. This year, our robot extensively uses a fully custom CAD designed and 3D printed structure and functional components, something still quite uncommon in our region. Nearly every major subsystem was designed from scratch, modeled, iterated, and manufactured locally. This gave us three major advantages: faster iteration cycles, better packaging efficiency, and mechanisms optimized specifically for this year's game. Constraint didn't limit our creativity, it forced us to engineer smarter. So, I introduce you to Sir Launcelot, our robot for this year's Decode season. This year's game quickly became very defensive. Robots were blocking each other, forcing contact, and disrupting cycles. So we made a bold decision. Instead of using a traditional drivetrain layout common in our region, we designed an inside based drivetrain. By recessing our wheels within the chassis profile, we reduced exposed impact points and protected our drive modules during aggressive defense. This allowed us to maintain maneuverability under contact, increase durability, and drive confidently through traffic. It wasn't just a mechanical choice, it was a strategic response to real match conditions. The most innovative part of our robot is our turret based hooded flywheel shooter. Most teams locally used fixed shooters, meaning the entire robot has to rotate to aim. We separated aiming from driving. Our goal with this robot was to allow for the drivetrain to be in any orientation and the shooter be completely independent of it. Our turret allows for 270 degrees of rotation. Our rotating turret allows independent horizontal alignment, while our curved hood allows trajectory and maintains consistent compression. This system reduces driver workload, enables rapid successive scoring, maintains flywheel velocity between shots, and allows us to shoot without fully repositioning. The hood geometry was carefully modeled in CAD and optimized for a consistent arc and exit angles. In a defensive game, this matters. Instead of turning the entire robot, we just adjust the turrets, maintain position, and score faster. All of this was automated by our programmers, and the robot is able to use its camera in order to auto align the turret. For our region, this level of mechanical integration and control is rare, and it represents a step forward in how we approach robot architecture. We learned that cycle time wins matches, and so we engineered a dual stage intake system to actively control and center the artifacts. Our first stage allows for centering and capturing of artifacts, and our second stage allows for more finer control as well as compression before the actual transfer into the shooter. Separating these stages reduce jamming and improve consistency. We realized that just for a single stage wasn't as efficient and reliable as having two stages. So we added that second stage. The result is a more faster and reliable intake system. In a country where resources are limited, collaboration becomes our greatest resource. Innovation wasn't just about parts, it was about people working together to elevate what FTC in Jamaica can look like. This robot represents more than a competitive machine. It represents engineering resilience. It represents raising the standard in our region, and it represents my commitment to pushing innovation forward no matter the constraints. Thank you for your consideration.